Q6644. If the grade of fuel used in an aircraft engine is lower than that specified, it may cause A. Detonation. B. Lower cylinder head temperatures. C. A decrease in power which could overstress internal engine components. The correct answer is A. Detonation. Detonation is an uncontrolled, explosive combustion of the air-fuel mixture within the combustion chamber. It occurs when the fuel-air mixture ignites spontaneously due to high temperatures and pressures, rather than being ignited by the spark plug at the intended time. Detonation can cause excessive pressure and heat in the combustion chamber, leading to engine damage or failure. Fuel grade and detonation. The grade of fuel specified for an aircraft engine is carefully selected to meet the engine's requirements, including its compression ratio and operating conditions. The specified fuel grade has specific properties, such as octane rating, that help resist detonation. The octane rating measures a fuel's resistance to premature ignition. Lower grade fuel and detonation. If a lower grade fuel is used, it may have a lower octane rating than what is required by the engine. This lower octane rating means the fuel is more prone to spontaneous ignition under high temperatures and pressures. As a result, detonation becomes more likely to occur during the engine's operation, leading to potential engine damage. Consequences of detonation. Detonation puts excessive stress on the engine components, including the pistons, connecting rods, valves, and cylinder walls. It can lead to overheating, increased wear, and possible catastrophic failure of these components. Additionally, detonation can cause a loss of engine power and efficiency, impacting overall aircraft performance. By using a lower grade fuel than specified, there is an increased risk of detonation occurring in the engine. This can have severe consequences, including engine damage, reduced power, and potential safety risks. It is crucial for pilots to adhere to the recommended fuel grade specified by the aircraft manufacturer to ensure safe and efficient engine operation. Q6643. To properly purge water from the fuel system of an aircraft equipped with fuel tank sumps and a fuel strainer quick drain, it is necessary to drain fuel from the A. Fuel strainer drains. B. Lowest point in the fuel system. C. Fuel strainer drains and the fuel tank sumps. The correct answer is C. Water contamination. Water can enter the aircraft's fuel system due to various factors such as condensation, precipitation, or improper fuel handling. Water in the fuel system can cause engine performance issues, fuel system corrosion, and potentially damage engine components. Fuel strainer drain. The fuel strainer is an essential component in the fuel system that filters out contaminants, including water, from the fuel before it reaches the engine. The fuel strainer is equipped with a drain, usually in the form of a quick drain valve or plug, that allows for the removal of any accumulated water and contaminants. Draining the fuel strainer drain is necessary to eliminate water present in the strainer and prevent it from entering the engine. Fuel tank sumps. Fuel tank sumps are designed to collect any water or sediment that may have settled at the lowest point in the fuel tanks. These sumps are equipped with drain valves or plugs for draining any accumulated water and contaminants. Draining the fuel tank sumps is essential to remove water that has collected in the tanks and ensure clean fuel is available for engine operation. Purging water effectively. To properly purge water from the fuel system, it is necessary to drain fuel from both the fuel strainer drain and the fuel tank sumps. This ensures that any water present in the fuel strainer and at the lowest points in the fuel tanks is removed from the system, reducing the risk of water contamination reaching the engine. By draining fuel from both the fuel strainer drain and the fuel tank sumps, pilots can effectively purge water from the fuel system. Regular water draining procedures should be followed as recommended by the aircraft manufacturer or maintenance guidelines to maintain fuel system cleanliness and ensure safe and reliable engine operation. 6706. The amount of water absorbed in aviation fuels will A. Remain the same regardless of temperature changes. B. Increase as the temperature of the fuel increases. C. Increase as the temperature of the fuel decreases. The correct answer is B. Water absorption in aviation fuels. Aviation fuels, such as Jet A or avgas, have the ability to absorb a certain amount of water. This water can enter the fuel system through various means, such as condensation or fuel handling procedures. Water contamination in fuel can lead to engine performance issues, fuel system corrosion, and potential damage to engine components. Temperature and water absorption. The capacity of aviation fuel to absorb water is influenced by temperature. As the temperature of the fuel increases, its ability to hold dissolved water increases as well. This means that at higher temperatures, the fuel can absorb more water. Fuel expansion. Fuel is subject to expansion and contraction based on temperature changes. As the fuel temperature increases, it expands, creating more space within the fuel for water molecules to dissolve and be absorbed. Fuel cooling and water separation. When the fuel temperature decreases, such as during overnight storage or colder weather conditions, the fuel contracts. This contraction can cause the dissolved water to separate and form free water droplets or accumulate at the bottom of fuel tanks, increasing the risk of water contamination in the fuel system. Managing water contamination. Understanding the relationship between fuel temperature and water absorption is crucial for managing water contamination in aviation fuel systems. Pilots and operators should be mindful of fuel storage conditions, avoid excessive temperature fluctuations, and follow proper fuel handling procedures to minimize the risk of water absorption and subsequent issues caused by water-contaminated fuel. In summary, the amount of water absorbed in aviation fuels will increase as the temperature of the fuel increases. Higher fuel temperatures allow for greater water absorption, while colder temperatures can lead to water separation and accumulation in the fuel system. Managing water contamination requires appropriate measures to control temperature fluctuations and proper fuel handling practices. 6645. What is the main reason fuel tank vents must be open? To allow A. Proper air pressure within the tanks for maintaining a steady fuel flow. B. Excess fuel to drain overboard when heat expands the volume of fuel within the tanks. C. Fuel fumes to escape from the tanks, thus eliminating the possibility of the tanks exploding. The correct answer is A. Fuel tanks in vehicles, especially those used in airplanes and automobiles, need to maintain a balanced pressure to ensure a continuous and smooth flow of fuel to the engine. The fuel system relies on a gravity or pressure differential to deliver fuel from the tank to the engine. If the pressure within the tank becomes too high or too low, it can disrupt the fuel flow and potentially cause engine performance issues or even engine failure. When an engine consumes fuel, a partial vacuum is created within the fuel tank. If the tank vents were closed or blocked, this vacuum could impede the flow of fuel by creating a negative pressure that restricts the fuel pump's ability to draw fuel from the tank. In extreme cases, this could cause fuel starvation and lead to engine stalling or loss of power. On the other hand, if the fuel tank vents were sealed and there was no way for air to enter the tank, it would result in positive pressure as the fuel is consumed. This positive pressure could cause fuel to back up in the fuel lines, leading to fuel leakage, fuel pump damage, or even a rupture of the tank. By keeping the fuel tank vents open, a balanced air pressure is maintained within the tank. This allows air to enter the tank as fuel is consumed, preventing the formation of a vacuum and ensuring a continuous fuel flow to the engine. The open vents also prevent excessive pressure buildup by allowing excess air or fuel vapors to escape, thus avoiding potential damage or safety hazards. In summary, the main reason fuel tank vents must be open is to maintain proper air pressure within the tanks, which ensures a steady fuel flow and prevents issues such as fuel starvation, fuel leakage, or tank damage. 6663. Running a fuel-length drive before switching tanks is not a good practice because A. Any foreign matter in the tank will be pumped into the fuel system. B. The engine-driven fuel pump is lubricated by fuel and operating on a dry tank may cause pump failure. C. The engine-driven fuel pump or electric fuel boost pump draw air into the fuel system and cause vapor lock. The correct answer is C. Vapor lock is a condition where the flow of fuel is disrupted or significantly reduced due to the formation of vapor bubbles within the fuel system. It occurs when the fuel vaporizes prematurely, typically in the fuel lines, fuel pump, or carburetor/fuel injector, instead of reaching the engine as a liquid. When a fuel tank is running dry, there is a higher likelihood of air being drawn into the fuel system. This can happen when the engine-driven fuel pump or an electric fuel boost pump continues to draw fuel, but instead, it pulls in air from the empty tank. The presence of air in the fuel system increases the chances of vapor lock occurring. Vapor lock can be problematic because air bubbles have compressible properties, unlike liquid fuel. As the fuel pump attempts to push the air bubbles through the fuel lines, they can get trapped and create a blockage in the system. This interruption in fuel flow can cause engine performance issues, such as loss of power, misfires, or even engine stalling. Furthermore, the presence of air in the fuel system can lead to increased heat absorption. Fuel helps dissipate heat generated by the fuel pump and other components, acting as a coolant and lubricant. When running on an empty tank, the fuel pump may not receive adequate lubrication, which can result in premature wear and potential pump failure. To avoid vapor lock and potential damage to the fuel system, it is generally recommended to ensure a constant supply of fuel by switching to a different tank before completely depleting the fuel in one tank. This way, the fuel pump will continue to draw liquid fuel, minimizing the risk of air entering the system and preventing the formation of vapor bubbles. In summary, running a fuel tank dry before switching tanks is not a good practice because it increases the likelihood of air being drawn into the fuel system, leading to potential vapor lock. Vapor lock can disrupt fuel flow, cause engine performance issues, and may even damage the fuel pump. It is advisable to switch tanks before one run completely empty to maintain a consistent fuel supply and prevent the introduction of air into the system.